Hello student, good morning. Dear student, now today we will study in this online class of physics part 10th. Chapter is electricity and topic is here the parallel combination of resistances. I told you in the previous video how we can find the arrangement in series combination of resistances, and then after today we will study in this online class combination of resistances in parallel. In parallel, there are two combinations because when we have required to increase or decrease the amount of current in the electric circuit, and there we will use two or more resistances in series and in parallel combination, because there are two ways, one in series and other in parallel. Now today we will see here the description of the parallel combination of resistances. Yesterday I told you about resistance, factor of resistance and the cause of resistance, and now you will see here the parallel combination of resistances. Then after you will solve some numericals which are based in series and parallel combination. After then we will study in the next topic, because here you will study for the revision classes, because I have finished all the chapters and topic, but I have started here the revision classes for the chapter electricity, and then after we will study about the magnetic effect of current, because there are two chapters for the second term. First is electricity and second is magnetic effect of electric current. Okay, so this is the important topic for the numericals. There we will solve some numericals which are based in series and parallel combination of resistances. Dear student, when we have the two or more resistances in parallel combination, then how we can find their equivalent resistance, you will see in there in the circuit diagram. Okay, what are the parallel and series combination? I told you about in series combination. Now today you will see here in about parallel combination. Okay, dear student, in parallel combination of resistances, when we have two or more resistances are connected in parallel, now the first end of all the resistances are connected to the first common point, and other end of all the resistances are connected with the second common point. Okay, when two or more resistances are connected in parallel combination, then the first end of all the resistances are connected to the first common point, and the other end of all the resistances connected to the second common point. Okay, and both end is connected to the battery and the key. Okay, here the equivalent resistance or combined resistance or net resistance across the end of conductor or resistances, okay, is equal to the reciprocal sum of all the individual resistances. We will find here. So here you will get, and here you will see that when two or more resistances are connected in parallel, let us consider R1, R2, R3 are three resistances. Let us consider three resistances are three resistors. You can say also three resistances are three resistors. Three resistances R1, R2 and R3, okay, are connected in parallel. And then the first end of all the resistances are connected to the first common point, and other end of all the resistances are connected with the other common point. Here is friend, the potential difference which are applied across the end of resistances which are same, but the amount of current which are different in this combination. You will see here, like this is the first resistor R1, and this is the second resistor R2, and this is the third resistor R3. First end, this is connected to the first common point, and the other end which are connected to the second common point. This is the battery. This is the R1, R2, R3. Okay? If here the current I flows through this resistance, now here it goes I1, This is I2, this is I3. And the potential difference which are applied across the end of resistances which are same. Potential difference which are applied across the end of resistances which are same in all the resistances or in each resistance which are same, but the amount of current which are different. We will use here the Ohm's law, and then after we can find the equivalent resistance. Now you will see here. What is the parallel combination of resistances? When two or more resistances are connected in parallel combination, then the first end of all the resistances are connected with the first common point, and other end which are connected with the other common point, and both common point which are connected, common point are the same point, and here connected with the battery and key. Then after here we will see that in this combination the potential difference which are applied, which are same in all the resistances, but the amount of current which are different in different resistances. And now according to Ohm's law, we can find here you can see that according to Ohm's law or apply Ohm's law, okay, we know that what we can write there, V is equal to IR. This is the relationship between potential and current which is given by Ohm, and so we can write there V is equal to IR, and here we can write the amount of current I is equal to V upon R. This is the expression first. But here we have to find in the first resistance R1, I1 is here, I1 which is equal to V upon R1, and next I2 is equal to V upon R2, and next I3 is equal to V upon R3. Okay? If we have the n number of resistances, then we can find there IN is equal to V upon Rn. But here we have taken three resistances, so we can write here I1, I2 and I3. And now we can find the total current flows across the end of resistances is equal to the sum of all the current which are flows through the different resistances. Now you can see that total amount of current I is equal to I1 plus I2 plus I3. Here I is equal to V upon R. This is V upon R1 plus V upon R2 plus V upon R3. Okay? By I1 is given here, I2 is given, I3 is here. Now we can write from question 1, 2, 3, 4, 5. What we will get? V by I is equal to V by R1 plus V by R2 will be by R3. Here we can take V is common. Now 1 upon R1 plus 1 upon R2 plus 1 upon R3. This is equal to V upon R. V is cancelled out. Now 1 upon R is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. This is the equivalent resistance. R equivalent, we can write there R equivalent is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. Hence, we can say that the equivalent resistance in parallel combination, which are the combined resistance in parallel combination, is the reciprocal, which is equal to the algebraic sum of all the individual resistances in reciprocal form, which is equal to the algebraic sum of all the individual resistances in reciprocal form. And one more thing, here the equivalent resistance or the combined resistance in parallel combination is equal to the always less than, which is the less than their combined, which is the less than the individual resistances. Okay? So now here we can find some numericals, like here when a number of resistances are connected in parallel, then their combined resistance is less than the smallest individual value. Suppose that we have the value of R2 and R3. R1 is R3, which is the value of 2 ohm and 5 ohm. Now, here we can find the R equivalent resistance, which is always, this is the less than for the individual resistance of any resistor. Okay, and we can find the equivalent resistance by this combination, and this is the combination of resistances in parallel, and here the equivalent resistance or combined resistance in parallel combination in reciprocal form is equal to the algebraic sum of all the individual resistances in reciprocal. Okay, and then after here you will see that the numericals which are based on series and parallel combination. Okay, like if we have this type of arrangement, like this is if we have the arrangement of this type distances, here we have given the battery. This is the key point. Okay, and here the value is given 5 ohm, 8 ohm, 12 ohm, and this is given 6 volt battery. 5 ohm, 8 ohm, 10 ohm, and here we have given this is the 2 ohm. Okay, and this point is here P, Q, R, and this is the S. We have to find the total equivalent resistance between PS. R equivalent resistance between P and S. Okay? Here you will see that first of all we can calculate this arrangement, then after we can calculate all the combination. Like this, here we have given the 2 ohm and 10 ohm which are in parallel combination. So we can write R equivalent is equal to R1 R2 upon R1 plus R2 between the two resistances. So here suppose that this is the R1 is 2 ohm and R2 is 10 ohm. So we can write here this is the 2 into 10 upon 2 plus 10. This is equal to 20 upon this is 12. Okay, 20 upon 12. Now we can write this is 4 5s are and 4 3s are 4 upon 3. 4 upon 3 means we can divide here 5. 4 5s and 4 upon and 4 3 are 12. Now 4 is divided by 5 is divided by 3. This is 1 times and this is 0.036 by 3 and now 1.66. So we can write 1.66. This is the ohm. Between only here. Then after here the arrangement is given in series. So we can find the total equivalent, the total resistance. Now total resistance is 5 ohm plus 8 ohm and plus 1.66. So we can show this arrangement in the next circuit diagram. This is the 5 ohm which is given, 8 ohm is given, and then after it becomes 1.66 ohm, and after then here you can show this arrangement. Okay, now you can see there. This is all here, all are connected in series combination. After then here we can write R equivalent is equal to 5 ohm plus 8 ohm plus 1.6 ohm. Now 8 5 13, 13 1 14. Now it becomes equal to 14.66 ohm. This is the answer. Total equivalent between PS between PS 14.66 ohm. If we have to find here the amount of current, then after we can use Ohm's law, V is equal to IR and I is equal to V upon R, and then after we can find. Now I will give here one question to solve for you, the homework, and you will do it like this. Right now calculate the equivalent resistance and the amount of current through the circuit diagram. Right now one question, there are 3 resistors. This is the P, R, A, B and C. Okay, This is given 5 ohm, this is 10 ohm, this is 15 ohm. And here we have given in this question 1 ampere current. 1 ampere current which flows across this resistor 5 ohm, and we have to find what is the current through the two resistors and what is the potential difference. First question is here, what is current? What is current through the two resistors? Two resistors means here 10 ohm and 15 ohm. And second point is here potential difference across AB, across BC and AC. And third is here total resistance, or combined resistance, or equivalent resistance, or equivalent cross AC. Okay, this is the question for you. This is the homework question. What you will do in this question? First of all, you will break the circuit. You will see there how many resistors which are in combination of parallel and which are in series. You can see the circuit diagram. I told you when the first end of all the resistances connected with the first common point and other end of all the resistances are connected to the second common point, then this arrangement is in parallel combination. But when the two or more resistances are connected one after other, now this type of combination is called in series combination. This is the important thing there. In series combination, the amount of current flows across all the resistances same, but the potential difference which are different in series combination. But in parallel combination, potential difference across the end of resistances which are same, but the amount of current which are different through the different resistances. I told you, and we have proved already, the equivalent resistances in series combination is equal to the sum of all, or the algebraic sum of all the individual resistances, but in parallel combination, the reciprocal of combined resistances which are equal to the algebraic sum of all the individual resistances in reciprocal form. Okay? And one more thing, you will use Ohm's law to find the amount of current and potential difference also. I told you, because that relation which was given by Sir as Ohm's law, Berg-Simon Ohm, and that is V is equal to IR. V is equal to IR. According to this relation, we can say that the amount of current which are directly proportional to the potential difference, or the potential difference is directly proportional to the amount of current, okay, across the end of resistances. But where the physical conditions remain unchanged, it means at constant temperature. Because at constant temperature we can find this relation, and that is the Ohm's law. And according to Ohm's law, we can use here V is equal to IR. Then after we can find the amount of current, I is equal to V upon R, and we can find the resistance by the combination according to in series and in parallel. This question you will do in your textbook, in your notebook copy. After then, if you cannot do it, and now you can write their comments, what is their problems, and I will provide the solution in the next video. Okay, thank you.